Good morning, dear students. So previously we have learned question number 1 and 2. Now today I am going to take question number 3. Just you see, here you are asked, find the local maxima and local minima, if any, of the following functions. Means point of local maxima and point of local minima we have to find out. Also we have to find out if there exist local maximum or local minimum values for the function. So find out the local maximum value of the function or local minimum value of the function. Our given function, first question you see, f of x equal to x square. As you know, x square is a positive quantity because any value you insert here, it will give a positive quantity. But we can know its local point of local maxima or local minima if there exists by the first derivative test. Okay, dear students? Here, step number 1. First you take the derivative of the function, that means f dash x. F dash x equal to twice x. Then you write equal to 0, means to know the zeros of the derivative, means zeros of this function. So to know zeros of this function, we write f dash x equal to 0. So we will say let f dash x equal to 0. That means twice x is equal to 0. So it gives us x equal to 0. So x equal to 0 is the point of either maybe local maxima or point of maybe local minima. Now to know, as you know, this graph is like this. It is a parabola passing through 0, that means. So that means here this can be the point of local maxima or point of local minima. Okay, now? So now let us know whether it is local maxima or local minima point of. So just before 0, that means here it is 0. Just before 0, just you take a point just to the left hand side of 0, very closest to 0, you take a point. Say I take here minus 0.01 or say minus 0.01, let us take. So let's take a point x equal to minus 0.01. At this point, what is the value of f dash x? You see, f dash x equal to, f dash x will be equal to 2 into minus 0.01. So that will be negative. No? Positive into negative is negative. So that means f dash x decreases before 0. No? F dash x decreases before 0. F dash x here is decreasing before 0. So it is less than 0, means negative. Again, take a point x equal to towards the right hand side of 0, you take a point, so 0.01. Then at that time f dash x equal to, f dash x, what will you get? That will be 2 into 0.01. That will give us a positive number. What do we see? That means before this 0, the f dash x is negative, and after 0 it is positive. So it is increasing after 0 and but decreasing before 0. That means we will say it is a point of minima. That is, since we can say f dash x is less than 0 before x equal to 0, and f dash x is greater than 0 before x after x equal to 0. Therefore x equal to 0 is a point of local minima. Therefore you can say now the value of minimum value of the function. Therefore minimum value of f is f of 0, that is equal to 0 square, that is equal to 0. This is our final answer. Okay, dear students, this is how we have to solve. Let's go to next question. Second question, g of x equal to x cube minus 3x. Let us take this similar way. So g of x equal to x cube minus 3x. So derivative of the function 3x square minus 3. So now let us, second step is what? After taking derivative, the second step is equate this with 0. So let z dash x be equal to 0. Then we get 3x square minus 3 equal to 0. So from here what we get? X square equal to 1. That means x is equal to plus minus 1. So that means there are two critical points. So that is plus 1 and minus 1 are turning points, or you can say critical points. Let us say critical points. So now we have to check whether these points are points of minima or points of maxima. Now let us take x equal to plus 1. X equal to plus 1, to the left hand side of 1 you take a number, say 0.9. so h, because you see this is 1, this is this is minus 1, this is 1. Towards left hand side of 1 you have to check how this z dash x is changing, whether sign will change or not at 1. At x equal to say 0.9, that is z dash x is equal to 3 into 0.9 square minus 3, which is this is 3 into, so this is like this, 3 into 0.9 whole square, that is equal to 0.81 multiply with 3, that will give us this one, that is this number minus this one is negative. No? And that means before this point the rate of change of the function is negative, so it is decreasing, that means it is going towards this one, it is decreasing, it is negative. Again towards right hand side of this x equal to 1, if you take a point, say 1.1, you take 1.1 very closest to, or 1.01, again at x equal to 1.1, then x equal to 1.1, g dash x is equal to what it will get? 3 into 1.1 whole square minus 3. No? So it says it is positive. It is positive. After calculation we will get a number which is positive number. That is z dash x is greater than 0 after 1, and z dash x is here, z dash x is less than 0 before 1. So what you can say, that is the function is decreasing before 1 and increasing after 1. So we can say this is a point of local minima. So this is a point of local minimum, that is x equal to 1 is a point of local minimum. So therefore minimum value is equal to f of 1, that is equal to g of 1. G of 1 means here you put 1, so g of 1, that means 1 cube minus 3 into 1, that is equal to 1 minus 3, that is equal to minus 2. Okay. Another point is minus 1, means at x equal to minus 1 we have to check whether it is a point of local minima or local maximum. See, towards left hand side of minus 1, this is suppose minus 1, towards left hand side of minus 1 you select a point, say minus that is 1.01, okay, or minus 1.1. think of very closest to minus 1 towards left hand side of minus 1. I take a point here, it is suppose minus 1.1, and towards right hand side of this suppose I take a point that is minus 0.9. okay, so let us check taking these 2 points. So when x equal to suppose minus 1.1, then z dash x will be equal to 3 into minus 1.1 whole square minus 3, that will be a number which is greater than this one 0, because 1.1 square is 121, 1.21, so it is 3 into 1.21 minus 3, and as you know, this will give us 3.63 minus 3, and which is a positive number, positive, that is z dash x is greater than 0 before minus 1. Towards the left hand side of minus 1, z dash x is greater than 0. And what happens after minus 1? Again, when very closest to minus 1, we are taking another point, minus 0.9. So when x is equal to minus 0.9, then z dash x, here z dash minus 1.1, we are putting here 1. So z dash minus 0.9 will give us 3 into minus 0.9 whole square minus 3, that will be 3 into 0.81 minus 3, that will be 3 1 is 3, 3 8 is 24, then point before 2 places, that is minus 3, that is negative, which is negative. So what you are getting, that is z dash x is, that is, we can say z dash x is less than 0 after x equal to minus 1. So we have seen here the this variation of change, or variation of sign. Z dash x was positive before 0, before minus 1, it was positive, it was greater than 0, and z dash x is now negative. That means it is a turning point of this kind. That means it was greater than 0 before this point, and means here at minus 1, suppose it is minus 1, so before minus 1 it was greater than 0, and after minus 1 it is less than 0, decreasing. So what you can say, this is a point of local maxima. So therefore minus 1 is a point of local maxima. So therefore maximum value is, maximum value of the function is f of minus 1, that is equal to f of minus 1 will be equal to, the function was minus 1 whole cube minus 3 into minus 1, that will give us minus 1 here, and here 3, that is 3 minus 1 is 2. So this is our answer. Okay, dear students, so this will be the final answer. Please see final answer. Let's go to next question, dear students. That is question number, Roman number 3. h of x equal to sin x plus cos x, and the x lies between 0 and pi by 2. That means in the first quadrant. So h of x is equal to, that is sin x plus cos x. So h dash x equal to cos x minus sin x. So then if you write equal to 0, h dash x, let h dash x is equal to 0. That means cos x minus sin x is equal to 0. So from here we can say cos x equal to sin x, and we can also write cos as sine of pi by 2 minus x, because cos x is the term, equal to sin x. So comparing both sides, what you can say, that is pi by 2 minus x equal to x, or you can say that is. So from here what you get, that is twice x equal to pi by 2, that means only x equal to pi by 4, that is pi by 4 is the point of that is critical point, you can say pi by 4 is the critical point generally. So we have to find out this it is a point of local maxima or point of local minima. For that, just since it is pi by 2, suppose this is the real line, this is pi by 4, and towards left hand side of pi by 4, so suppose I select pi by 6, smaller value, and towards right hand side of pi by 4 I select suppose pi by 3. No? So at these 2 points we will see what is h dash x, its sign changes or not. No? So before pi by 4 and after pi by 4. So when x equal to suppose pi by 6, then h dash x means h dash pi by 6, let us say, that is equal to cos pi by 6 minus sin pi by 6, and this is cos pi by 6 is root 3 by 2 minus 1 by 2. Root 3 is greater than 1, that means root 3 minus 1 will be greater than 0 because it is bigger number than 1. So that is a positive quantity. We can say it is a positive quantity. It is greater than 0. That is h dash pi by 6 is greater than 0. Now let us see h dash pi by 3 is greater than 0 or less than 0. Again, when x equal to pi by 3, what do you get? H dash pi by 3. H dash pi by 3 is cos pi by 3 minus sin pi by 3. Okay. So here cos pi by 3. Cos pi by 3 is what? That is cos 60. That means 1 by 2 minus root 3 by 2. Okay. Sin pi by 3. So you see root 3 is greater than 1. That means 1 minus root 3 will give you a negative quantity, which is less than 0. Less than 0. That is h dash x pi by 3 is less than 0. That means what is happening here? That is before pi by 4 the value was more than 0, and after pi by 4 it is decreasing. So that means the function's graph will be like this. Okay. So that is after pi by 4 it is decreasing. So here at pi by 4, the value is the sign is changing as the function is passing through pi by 4. The sign is changing. Before pi by 4 it was positive and now it is negative. Then you can say pi by 4 is the point of local maxima. So we'll write one line here this way. Dear students, I am writing here itself. So since space is there, so I am writing here, since, we'll mention like this, since h dash pi by 4, h dash pi by 6, sorry, pi by 6 is greater than 0, and h dash pi by 3 is less than 0. That is h dash x is changing its sign from positive to negative as it passes through. Pi by 4. Therefore, point of local maxima pi by 4 is point of local maxima. Therefore, the maximum value of the function is, just we are writing here only. Therefore, maximum value of the function is equal to h of pi by 4. That is sin pi by 4 plus cos pi by 4. Sin pi by 4 1 by root 2. This is also 1 by root 2. That means it will be 2 by root 2. 2 by root 2. If root 2 you multiply on which numerator and denominator, it will be 2 into root 2 and it will be 2. 2 will get cancelled, it will become ultimately root 2. So this is the maximum value. No? Maximum value of the function. So dear students, you go through question number 3, the remaining questions. So that will be your homework. Your homework is question number 3 today. Question number 3. So you solve and show me. Okay dear students.